All right, guys, it's balancing chemical equations. I know you know the 4 steps. 1, write the equation. 2, count the number of atoms. 3, use coefficients to balance those atoms. And then 4, look back and check. But what exactly does that look like and what does it mean? Let's start with something simple. Let's talk about the electrolysis of water. Water starts with H2O. That's going to be on my reactant side. Remember, my reactants are always on the left. Water winds up breaking down when you use electrolysis on it to hydrogen gas and oxygen gas. So step 1 says to write the equation. That's my equation for the electrolysis of water. In front of every compound or molecule, you want to make sure you leave a little space. This should look familiar from that god-awful test I made you all take a few months ago. So now step 2 says to count the atoms. This is where I call it doing your reps. REP means reactants, elements, and products. So it sort of looks like a gigantic seesaw. My reactants are on one side, my elements are in the middle, and my products are on the right-hand side. So in the reactants, I have hydrogen and I have oxygen. That's the different kind of elements that I have. On the reactant side, again, this is my R, this is my E, that's my P. On the reactant side, how many pieces of hydrogen do I have? This is where the subscript comes in. I have 2 pieces of hydrogen in every single molecule. I have only 1 piece of oxygen. I'm going to count the same atoms, but on my on my product side. On the product side, I have 2 pieces of hydrogen, and I have 2 pieces of oxygen. Okay? Now, step 3 says to use coefficients in order to balance this equation. Changing my pen color on purpose. So my hydrogen has 2 coming in and 2 going out. And we know the law of conservation of mass says whatever goes in must also come out. So right now it looks like only 2 pieces of hydrogen went in and 2 pieces of hydrogen went out. I'm good. Let's talk about the oxygen, however. Only 1 piece of oxygen went in, but I have 2 pieces of oxygen that came out. So I need to fix, using my coefficients, this is step 3, the number of oxygens that are coming in. So I need to try and increase the number of oxygens to the number 2 in order to have it balance out. So if I come up here and use a coefficient and say, never mind, I want 2 of these molecules. I am now saying that I have 2 of 2 hydrogens. So I am now going to have 4 reactant atoms of hydrogen. But I'm going to have 2 reactant atoms of oxygen coming in. Well, the good part here is that now my oxygen is balanced. I have 2 oxygen that came in. I have 2 oxygen that went out. But now I don't have my hydrogens in balance anymore. I had 4 coming in. I need to have 4 coming out. So once again, I'm still on step 3. I need to change my coefficients. If I change this to a 2, that means that I have 4 pieces of hydrogen. Each compound has 2. If I have 2 compounds of it, I wind up multiplying them together, and I wind up with 4 hydrogens. This is looking good to me. So I'm going to move on to step 4. Step 4 says to look back and check. Every single element needs to have the same number of reactants as products. So let's start with hydrogen. I have 4 coming in, I have 4 going out. That looks good. Oxygen, I have 2 coming in, I have 2 going out. That looks good. So that means that my balanced equation for the electrolysis of water would be 2 H2O yields 2 H2 plus, you can leave it blank, or the inferred number 1, O2. Make sense? Okay. Now that you get the general idea of how to practice our balancing of equations, let's try one more. When we went and burned the sugar in our closed chamber reactions, let's try the burning of sugar or combustion of sugar. If you remember, sugar is C6H12O6, and we burned it. And in the end, we came up with pure carbon and water. If we go in on step 1 and write the equation, make sure that you keep putting those blank spaces before every one of your molecules or compounds. Step 2 says to count the atoms. This is where we want to remember to do our rep. Rep, reactants on one side, elements down the middle, products on the right-hand side. So our possible elements are carbon, hydrogen, and oxygen. Let's count. I'm on step 2. On the reactant side, I have 6 atoms of carbon. I have 12 atoms of hydrogen, and I have 6 atoms of oxygen. On my product side, I have 2 atoms of carbon, 2 atoms of hydrogen, and just 1 atom of oxygen. Let's move on to step 3, using coefficients in order to balance this equation. Well, the first one that catches my eye is the fact that my oxygen has 6 coming in but only 1 going out. So I need to make sure that I get this number at the very least up to 6. So what coefficient would I use in order to make sure that my reactant side comes up to 6 oxygen? I'm going to use a coefficient of 6. When I do, I'm also affecting my hydrogen. 6 times 2 at a cluster of hydrogen gives me 12 atoms of hydrogen. But that 6 also carries through and gives me 6 atoms of oxygen. So far, so good. But I need to keep using more coefficients. Let's look at my carbon. My carbon has 6 coming in and only 2 going out, but they come in sets of 2. So I'm still using my coefficients. I'm going to try by putting in a 3 as a coefficient. When I put in a 3, groups of 2 winds up giving me 6 pieces of carbon. I can go back to step 4 where I look back and check. Carbon, 6 going in, 6 going out. That looks good. Hydrogen, 12 going in, 12 coming out. That looks good. Oxygen, 6 going in, 6 coming out. That's also balanced. So my balanced chemical equation for the combustion of sugar is C6H12O6. I don't have to put a number 1 in here. It's inferred. Yields 3 pieces of carbon and 6 molecules of water. It's quite that simple. Now it's your turn. I need you to do some practice yourselves. Remember when we did photosynthesis in 7th grade? That's right. That equation, if anybody remembers, was carbon dioxide and water in the presence of sunlight yields sugar and oxygen. We want to put a little dash in front of each of our molecules. I want you to try this yourselves at home. Don't forget, do your reps. So I've written the equation. Now it's time to do step 2. You might want to pause this video just so that you can count your atoms yourself. It gets tricky here. The number of carbons I have coming in is just 1. The number of oxygens that I have come from 2 different molecules. So from one molecule, I'll wind up having 2. But from this other molecule, I have another 1 and 2 atoms of hydrogen. And it happens again on my product side when it comes to my oxygen. My first molecule gives me 6 atoms, but my second molecule gives me 2. So let's go for something easy first. Let's hit up the carbon. 1 going in, 6 coming out. We're now on step 3. I'm going to want to put in a coefficient to bring up those carbons. So that brings that carbon up to 6. But when I put that coefficient in here, it's also going to affect those 2 oxygen. I no longer have 2. I'm now going to have 12. So carbon looks good. 6 going in, 6 coming out. My hydrogen has only 2 going in, but 12 coming out. I need to fix this so that I have 12 hydrogen at very least going in. But my hydrogen comes in groups of 2. So how many groups do you think I'm going to need? If you said 6, you're on the right track. But my 6 coefficient has to multiply through all of my elements. So 6 times 2 gives me 12. But 6 times this 1 gives me another 6. So the good news is right now my carbon looks good. It's got 6 atoms going in and 6 atoms coming out. My hydrogen has 12 atoms coming in and 12 atoms coming out. But my oxygen has 6 plus 12. That's a total of 18. I have 18 atoms of oxygen going in, but I only have 8 atoms of oxygen coming out. I need more oxygen. I don't want to mess with this whole system because if I do, I'm also messing with my carbon and my hydrogen, which I just finally got balanced out. I only need to mess with the oxygen count. So if I already have 6 coming from here, that means I need 12 more, but they come in groups of 2. I'm going to use my coefficient of 6. 6 times 2 at a pop gives me 12. Let's move on to step 4. Let's look back and check. And it comes to carbon, 6 atoms in, 6 atoms out. When it comes to oxygen, I have 18 going in, 6 plus 12 is 18 coming out. And hydrogen, 12 in is 12 out. All 3 of the elements are totally balanced, making the balanced chemical equation for photosynthesis, if you remember from 7th grade, 6 CO2 plus 6 HGO in the presence of sunlight yields C6H12O6 plus 6O2. It's quite that simple. Now, time for you to try some of these on your own. You're going to be assigned some homework. Go back to your Google Classroom and good luck. Let me know in the comments if you're struggling, and we'll try some more.